Okay, let's get started. Y'all doing okay? Y'all have a good weekend?
Chill.
Yeah? We have an exam a week from today, right?
Yeah.
No, wait, hold on. Is that right? No, it's next. Yeah, it is next Wednesday. Okay, so week from today we have our first exam. It will cover everything that we've done. So chapter 1 in its entirety, 2.1 and 2.1 and 2.2. We are covering 2.1 today. We'll cover 2.2 on Monday. So that's going to be kind of tough because we're going to cover 2.2 on Monday, and then you're going to have a test over that material on Wednesday. So you need to be prepared for that, all right? We've looked at all of these types of limit forms, right? Anytime we see 0 over 0, we have to do some sort of algebra. Infinity over infinity, some sort of algebra. What about fixed over 0? What is it? What? 1? No?
No, that's the other one.
What it is?
That's just not 0. It goes to infinity or negative infinity or does not exist. This is the one with 3 different cases. This? 0. This goes to 0. In last class, at the very end of the lecture, I talked about how when we said fixed, I meant that you could also be talking about bounded, right? And I showed you an example of like sine of something over something went to infinity, and that goes to 0 also. What I did not address, which did come up in the homework, and what I'm going to start class with today, is infinity minus infinity. So let's talk about that, and then we'll move on to 2.1, all right? We're not in 2.1 yet. So what if we get something like infinity minus infinity? This is still what we call an indeterminate form, and we have to figure out kind of like who wins the battle here, right? One of your terms is getting big, the other one's getting big, you're subtracting them. What happens? So here's an example. We'll start out with a relatively easy one. Let's go x to the third minus x to the fifth. So just look at that for a second. Just tell me, what does your instinct tell you is going to happen? What is going to happen? What do you think?
The negative infinity is going to be bigger because of the...
You think this one's going to be bigger, right? Because it's to the 5th power. This should dominate a cube, right? So this should be bigger than that. So we should probably get like negative infinity. But we need a more systematic way of doing it. So the common technique to go after infinity minus infinity is to factor, to try and turn it into a product. All right? So that's what I'm going to do. I'm just going to rewrite the limit. And lucky for us, this has a GCF. I can pull out x cubed, be left with 1 minus x squared. All right? And now just run through the limit again and see what happens. So you get a number that's huge, you cube it, that's going to be infinite, right? So you have infinity here. So this has the form here of infinity times, because this is multiplication. And then 1 take away a huge number, 1 minus a huge number should be negative, a huge negative number. So negative infinity. And now if you multiply a very big positive number times a very big negative number, you're going to get a very big negative number. So your answer is negative infinity. And we're done. That's it. Okay?
So that's what's going to be on the test, right?
So yeah, the test will just be 10 of those, and that'll be it. No, it will not. Now here's something more like what you might see on the test. What if you have, I don't know, 2 square roots of x minus 15 fifth roots of x? X to the what? Okay, so, that's the 5th root of x, that second one. Let's just first check to make sure we have infinity minus infinity. Infinity square root times 2, still big, right? 5th root of a huge number, still big, times 15, still big. So this is infinity minus infinity, right? That's the form we have. So when I see infinity minus infinity, I start to think about factoring. can I factor? Yeah, how do we deal with this? So, go ahead.
I was gonna say, couldn't you, no, well, no, yeah, you could do that. To get rid of the roots, we could put it into the form of like to the 1/2.
Yeah, we're going to convert this over to what we call rational exponents. Raising something, square rooting something is the same as raising it to the 1/2 power, right? And what about the 5th root of something? That's the same as raising it to the 1/5. So that's the same expression, right? Now we need to try and find something they have in common to pull out. And right now, there's no number, right? The numbers, there's no common factors there, so we've got to leave those alone. How can we factor something out of there? X to the 1/2, maybe?
Well, yeah, you could.
Could we?
Don't you have to factor out a 1/5? That's smaller.
Yeah, that's
Yeah, that 1/5 is smaller, right?
I think so.
So at this point, there are various ways to go about this. All right, you can factor out an x to the 1/5 right now because it's the smaller of the two. What I like to do, just so that we're all seeing it, hopefully, is I like to rewrite these with a common denominator. So if I take the fraction 1/2 and 1/5, common denominator would be 10, right? So I could rewrite the 1/2 as 5/10. And I could rewrite the x to the 1/5 as x to the, what, 2/10? Like that. People usually have a better understanding here of which of these is smaller, and they realize, look, I have 2/10 in 5/10, don't I? So 2/10 would be what they have in common, and I could pull that out. So if I pull that out, limit x goes to infinity, I have x to the 2/10, and then what do I have here? 2x to the 3/10. You add the exponents together, right? And you need to be able to get back to 5/10, right? So when I multiply this times this, you add the exponents. 2/10 plus 3/10 is 5/10. And then out of here, when we pull that x to the 2/10 out, all that's left is minus 15. And then at this point, you can just,
why is there still an x in front of the 2?
an x in front of the,
Behind the 2, I'm sorry.
we only pulled 2/10, x to the 2/10 out of this.
Oh, okay, so we didn't pull the whole. Okay.
Yeah, we pulled this whole thing out. The reason we chose this is because this power is smaller than this power. So if you look back at this is really x to the 1/5, right? So if you take a big number and you take the 5th root of it, it's still big. Infinity times, this is the, what, 3/10 root? You can't do anything to that. Like you can't say, you can't, like this one you can turn to 1/5, this one you can't. So that means you're taking the 10th root of x cubed. That's what that means. So take a huge number, cube it, take the 10th root, it's still big, right? So this is going to be 2 times infinity. So infinity minus 15, still infinity. Infinity times infinity, positive infinity. That's your answer.
So we're solving for a positive or negative infinity?
Yes, well, a student asked me that last class. And I couldn't come up just off the top of my head of an example that would not do that. But I'm not willing to go out and say that every time you see this, it's one or the other. There might be a number where they compromise and they come to the same, like they just go, it goes to 4, the number 4. You know, it may happen. I have to think through that a little bit more. So, now that other one where we had fixed over 0, that was 3 possibilities, right? Infinity, negative infinity does not exist. That was it. All right, that's it. That's it for that part. We're going to start 2.1. Chapter 2 is called Derivatives. All right, derivatives. And if you ask any Cal 2 student what Cal 1 was about, a lot of them will say derivatives. It's all about differentiation, derivatives, derivatives. So we're actually now starting what we're going to spend the rest of the class doing, and that's this, all right? I know you all watched the video for 2.1, and so I'm not going to spend a lot of time going over it as far as the material that was in here, but I will point out the major things. Whoa. Okay, here we go. So the main idea here, let's see if y'all can help me develop the main idea here. We are going to look at a function, right? We are going to pick a point on the x-axis somewhere, which just pick it. There we go. That's called A. And then we go up here to a point right there. And we are trying to find the slope of the tangent line to that curve at that point. So imagine if you put this line on here, right? It would be a line that just barely touches through and almost kind of doesn't balance, but it just kind of fits nicely onto the curve, almost like a tangent line would be to a circle, right? That's the goal. That's the goal. Yes? That's what y'all got from the video? And the way to get that tangent line, to get its slope, is we start by picking another point over here, right? Which we called what? Anyone remember? X. Now there's two different ways to do this, right? One way is to call this X. And then once you have these 2 points, there's definitely a line through those 2 points. But to get the tangent line, we have to move this point closer and closer to that one. So I'd kind of slide this over, and maybe when I get to about, let's say here, now the tangent, or the secant line looks like this. And as I put it here, then it looks like this, and get closer and closer, and it gets better and better, and eventually you put the 2 points right on top of each other, and you have the tangent line, right? The slope. So with that concept in mind, we create a formula for the slope of the tangent line, and it is slope m of tangent line equals the limit. Now we had to move that point x over here to this point, right? We had to move that one over there, so we let x get closer to a. That's what our limit is. X is going to approach a of what? Anyone know?
Is it the actual, like the rise of x?
F of x minus f of a over x minus a. Now I went through the whole development of that formula in the video. This is just rise over run. That's all that is, right? It's the change in the y coordinates, the difference in the y coordinates, minus the difference in the x coordinates. That formula needs to be hardwired, okay? It is actually the difference quotient from college algebra. That's all it is, but we're throwing one thing in front of it. We're throwing a limit in front of it, right? That needs to be put into the memory banks. Got it? That was one version. Another way to get the same exact answer, so an equivalent formula, is to do a limit, but this time we change one thing. Instead of calling this x, we call it a plus h. So all that is whatever this number is, add something to it. And if you add something to it, you're going to be to the right. And then to move that point along the curve back this way, we just need to make the thing that we're adding get smaller and smaller. So this limit will have what down here?
A plus h approaches
H approaches 0. Just h. Because look, if I let that number get small, right, h, won't it get closer to a? Yes? And then the formula up here, the rise over run, becomes f of a plus h minus f of a over h. Those two formulas need to be hardwired. And I'm not a big memorization person, all right? Personally, I'm not. That's why I allow you to have the formula sheets on the exams, right? That you can refer back to trig stuff. But these two you need to know in this class, all right? Just put them in there. However you need to do that, do it. Also, I've always had a rule in my classes that if you get a permanent tattoo of any math formulas, that's allowed on the test. Okay?
Don't test it.
It has to be permanent. Has to be permanent. No henna, no. Sorry.
Get it removed after we're done.
Yeah, you can just go get laser removal afterwards. No, I'm kidding. Don't do that. One of these days, I always joke about it. One of these days, someone's going to come in, hey, check it out, man. I'm like, holy shit. I was kidding.
You think they allow that in the SATs?
I don't know. They probably make you like cover your arms up or something. I don't know. Let's not go there, all right? Okay, so what I'm going to do to start this out is I'm going to make sure we understand what this does, right? If we have a graph, someone provides us a function, and they provide us a point, we should be able to calculate the slope of the tangent line at that point with either one of these. It's our choice. So I'm going to give our first example. I'm put it up here. We're going to calculate the slope of the tangent line using both formulas so you can see them both in action, so you can see how they differ. All right, sometimes there's really no difference. The algebra is pretty much equivalent. Sometimes this formula is going to be easier to use than this formula. Sometimes this one's going to be easier to use than that formula. And the only way to really know is to actually get in there and look at what you're going to have to do. All right? So on the first example, let me write the function down over here first because I want to show you something on the board. We're going to look at the function f of x equals x cubed plus 2x minus 5. And let's look at it at the point 1, let's see what happens with 1, negative 2. I want us to find the equation of the tangent line at that point. Now pay attention to what I just said. Find the equation of the tangent line, right? What do these two formulas give us? The slope of the tangent line. This does not give you the equation. It gives you part of the equation. It gives you the slope of the line, right? But it doesn't give you the whole thing. So I'm going to work that problem out. But before I do it, I'm going to graph it, just so you can see what we're trying to do, all right? So I'm going to pull up a program that I have on my computer. I'm sure there's much better graphing stuff out there. But this works. So I'm going to have this graph x cubed plus 2x minus 5. I think I got that right. Hold on a second. This is WinPlot. There we go. Okay, now I'm going to have it graph. Like I said, there's probably better programs out there, okay? All right, can you all make out that point? See the curve? This is the curve. This is the point 1, negative 2, x is 1, y is negative 2. We are going to try and find the equation of the line that would run tangent to that curve at that point. Tell me, from looking at it, is our answer for the slope of the tangent line going to be positive or negative? Negative? Positive?
Wait, yeah, positive because it's going to
Positive. The slope of the tangent line, do y'all see that it should look something like this, somewhere around there? Okay, slope of this line is what? 0. Positive slope, right?
Yeah.
Negative slope. So we can tell just by looking at this, we should get a positive answer. And it should actually be pretty big, shouldn't it? Because this slope right here, right? A perfect diagonal has a slope of 1. A slope of 2 is steeper. 3, 4, 5. And actually, you can't have a vertical line. A vertical line doesn't have a slope. It's undefined. So if I was like, just tilted a little bit over, that could have a slope of like 10,000. Right? Rise over run. Up 10,000 over 1. Now, the slope of 1,000,000 would be like almost vertical, right? Up 1,000,000 over 1. But it's impossible to get vertical. Do y'all see that?
Yeah.
So we should expect this answer to yield a relatively large positive number. If we get something else, we probably messed up. All right, so let's do it. What's going to be cool is once we get our answer, we're going to actually go back to that program. We're going to type in, we're going to graph that line, and we'll know if we got it right just by looking. All right, so everyone has the function here. Let me see, is that coming out on camera? Yeah, I think you can see that. That's good enough. All right, so let's start out. Let's do the top one. Let's start with the slope of the tangent line. The slope of the tangent line will be equal to the limit as x approaches a of f of x minus f of a over x minus a. That should just roll off your tongue at some point. Like you shouldn't even have to think about it. It's just blah, blah, blah. It's like breathing. I'm kidding. All right. Do we know anything in that formula that can be replaced? The a, right? So remember we said you take a function, you pick a point, right? You pick an x value. We know what the x value is. It's given to us right here. I told you where to go look, right? This is a. A is 1. So I want you to now rewrite the whole formula and replace all your a's with 1s. We're taking the limit as x approaches 1 of f of x. Don't replace the x. Replace the a. We good there? Any questions? We're good then? Okay. Now, at this point, we need to figure out what the top left corner and the top right corner of this limit become. So, what is f of x? Nope, f of x. What's f of x? Well, that's the original function, isn't it? That's the function we were given. That's the thing we're looking at, right? So I need to replace that top left corner with that exact expression. X cubed plus 2x minus 5. That's f of x. We done up top? No. Minus f of 1, right? F of 1. F of 1 just means plug 1 into the function. Well, we already know what the answer is going to be, don't we? What is it? Negative 2. I mean, you could plug 1 in, but doesn't this tell us exactly what will happen if you plug 1 in? So I already know this point right here was f of a. Now, please be careful, because on the test that you're going to have a week from today, I don't usually give you the point, like 1, negative 2. I'll just say, find the equation of the tangent line at 1. So that means you need to know a is 1, and then when it comes to that f of a part, you need to actually plug 1 in and get the negative 2 yourself. All right, just be ready for that. Okay, so I'm going to replace this. This is a minus sign, but I'm replacing this with negative 2. So be careful, that's a negative negative. That will become a positive over x minus 1. At this point, we've plugged everything in. Now we just need to evaluate the limit. We know right away, without even doing anything, that this is 0 over 0. It's guaranteed. And the reason why is because that was the whole problem when we moved that second point on top of the other one. We knew we were going to get 0 over 0. Rise over run was going to become 0 over 0. Remember, that's why I started this class out? Like we're going to try and get around the 0 over 0 thing? Okay, so we know that 0 over 0. So right away you can start to do some algebra to clean it up, to make it better. Our goal will be to make the bottom not go to 0. So we're going to want the x minus 1 to cancel, right? Like a factor. So let's just clean up the top. Limit x goes to 1 of x cubed plus 2x, what? Minus 3 over x minus 1. And this is where I'm curious to see what you're going to do.
Would you introduce the one over x?
Oh, no, okay, I'm glad you said that. Introduce 1 over x. What you're thinking is you're going to try and turn this into, like, get rid of the highest power down there?
Yeah.
We only do that when we have what? Infinity over infinity. Okay? So it's good that your neurons are actually firing thinking of that, but it's for the wrong case. It's when we have infinity over infinity that we do that. We have 0 over 0.
Is there a way to factor?
Yeah, that's, everyone should be looking at that top and be wondering how to factor it. So, what do you think? It would be nice if that was what? A 2, but it's not. Yes?
Can we divide?
How do you mean?
Like, can we divide the top by the bottom?
How?
Like, x cubed is 2x minus 3 divided by x minus 1.
Yes? I'm just waiting for you to, yes, but I want you to say it. How do you want to divide it?
Like, using synthetic division.
Synthetic division or long division, either one. Either one. Okay? Now look, think about this. Does this factor? Well, not easily, right? Not easily. But does it factor? Yes, guaranteed. Here's why I know that. Because when I plug 1 into this up here, I get 0. Right? When I plug 1, I get 0. And that means that this does break down to be something. It's something times something. I know one of the factors has to be x minus 1. Guaranteed. This other one is like a mystery to me right now. Because when I plug 1 in, I should get 0, and that means that x minus 1 is a factor. This goes back to college algebra. If x equals 1 gives you 0, then x minus 1 is a factor. That ring any bells at all?
Yeah, because it's a root.
It's a root, right? If x equals 1 is a root, then x minus 1 is a factor. All right, so we know that this does divide in. All right, so now you can use long division or synthetic division. Let's take a vote. Long division? Okay, synthetic division. Okay, I think the synthetics have it. You can only do synthetic, though, if the denominator is linear. Yes, if it's a linear factor, which it is. So I'm going to do synthetic division right now. I'm just going to do this on the side. This is scratch work over here. I'm going to take the numerator, polynomial, I'm going to write it in that upside down synthetic division box. And what numbers am I putting in there?
0, like 1.
1 for the coefficient of x cubed, 0 for the coefficient of x squared, 2 for the coefficient of x, and minus 3. Then on the outside of this synthetic division box, I'm going to put a 1. Remember, whatever this number is, it's the opposite of that which goes out there. So 1 out here. So look, if you need to go back and review synthetic division from college algebra, you may do so. That's if we did not have this. If we were just trying to figure out how that factors, we would do that list. Yes, exactly. But we know that that goes in. It's just a matter of what is it once it divides in. So now what we do is synthetic division. So we drop the 1, right? 1 comes straight down. 1 times 1 gives us 1. We put that here. Drop down again. 1. You know what I'm doing? Drop the 1 down. 1 times 1 is 1. Add straight down. 0 plus 1 is 1. 1 times 1 is 1. Add straight down. 2 plus 1 is 3. Multiply 1 times 3, you get 3. And then you add straight down and you get 0. And the 0 tells us that it factored, that it actually is a 0 of the function. So here's where I am. I go back to this and I say, all right, well, this limit, when I divide this into this, becomes something. And that something that it becomes is indicated by these 3 numbers right here. These 3 numbers tell us what the answer is. Do you remember how these 3 numbers tell us the answer?
Drop 1 above, so it's x squared
Yeah, you look, the highest power here was x cubed, so you know that this is going to be a 1 sitting in front of x squared, then plus a 1 in front of an x, and then plus a 3 with no x's. Yes? Okay, so this becomes x squared plus x plus 3. That's it. We no longer have division by 0, do we? We good? Plug in 1. What do you get? 5. Is that a positive number? Yes, we said it would be positive, right? This is a slope of 1. Slope of 5, I don't know. Hopefully it's about like there, right? All right, have we answered the question? Find the equation of the tangent line. We have only found the slope. Now we go after the equation. So here's how we do the equation. For the equation, bless you, of tangent line, we go back and we think about equations of lines. And back in college algebra and even before that, we had this one. We used to love this one. We still love it. Y equals mx plus b. This right here is a great equation for a line because it has the slope in it, right? And also has this other number b, which is the y-intercept, yes. So if I know what the y-intercept is and I know what the slope is, this is a great formula, right? I don't know this. I don't know the y-intercept. Do I? What I do know is I have the slope of the line, right? And the only other information I have is I have a point that lives on that line, right? I have a point and I have a slope. So the other formula for a line is what we call the point slope formula. 7th grade? Yeah, it's y minus y1 equals m times x minus x1. That one. That's the one we're going to use. Here for us in this problem, we already know that m is 5, right? And we also know that a point, any point that lives on the line, would be that point over there, 1, negative 2. Yeah? So x1 is 1, and y1 is negative 2. So just go to that formula and just replace everything. And we get y what? Y minus y1, so y minus negative 2 equals, be careful with the sign there, right? Equals 5 times, that's m, x minus 1. And then we can clean it up. Y plus 2 equals 5x minus 5. I distributed. And I'm going to get the y by itself, because we like to look at lines when it's solved for y, right? We like that form. So subtract 2. Y is 5x minus 7. There it is. Now it's in slope-intercept form, right? This is y equals mx plus b. So we could graph this now, and it should hit that curve at that point, and it should run tangent to the line. You ready to see if it does? Yes.
Backtracking to the synthetic.
Yes.
To the synthetic
Uh-huh.
formula.
Yes.
The one that we use to distribute, it goes into x minus 1, right?
It goes into x minus 1?
If memory serves correctly from my last class. Does that mean from it goes with the numerator of x squared plus x minus 3, then takes out the numerator and denominator of x minus 1? Is that? I'm not talking that time.
Well, I think what you're saying is that the one up there in synthetic means that x minus 1 is a factor, so that it breaks up into 2 pieces, then you could cancel it. I think that's what you're saying. That is correct. But we don't need that much. We can just take that end answer, those 3 numbers we got, and just rewrite.
It's just a refresher.
Yeah.
Memory refresh. Thank you.
That is correct. Okay, so I'm gonna go back to my graph. Bring it up here. I'm gonna type in what, 5x minus 7? What do y'all think? Do you think we got it? You don't feel good about it? Okay, 5x minus 7. Here we go. Moment of truth. There it is. All right, that worked. Okay? Theoretically, we can do this for any function. Doesn't have to be a polynomial function. It can be a rational function. It can be square roots. It can be trig functions. Any function. If you can compute the limit, you can find the slope of the tangent line. If you can compute the limit. That might become tough at some point.
So does that mean if the limit is going to infinity, it can have a tangent line?
If the limit is going,
If it's, yeah, sorry.
if the function goes to infinity,
Yeah,
like if the function just takes off like that,
yeah, because technically you can't calculate that, so.
well, if you go and pick a point on the curve and go up to that point, then you should be able to get a tangent line. There are some curves that you cannot find tangent lines of. And I'll give you a simple example. The absolute value curve. You cannot find the slope of the tangent line at the bottom of that curve. We call this a corner, and you don't have, derivatives do not exist at corners. And it's just, think about it. I mean, if I flip it over, I mean, if you pick a point right to the left of this, the slope of the tangent line should be this, right? But if I pick something to the right of it, it's going to be pitched down like this. So as you come in from both sides and try and figure out what the slope of the tangent line, it's not going to the same place. So, well, let's investigate that later, though. I think what we need to do now is repeat this problem again with the other formula. Maybe the other formula would have worked better or easier. So I'm going to now write slope of the tangent line is equal to limit h goes to 0. Formula is f of a plus h minus f of a over h. We can replace what here? A with 1. Okay, so do you all understand that this formula is universal? And then the specific problem tells you what A is, and then it tells you what function you were working with. But this by itself works for all functions. Okay, so I'm going to replace the A with 1. I'm going to go f of 1 plus h minus f of 1 all over h, like that. And then I have to plug in. So let's see how this is different than the last one. When I say f of 1 plus h, I actually have to take 1 plus h and plug it in for x here and here. Do you agree? And then just, write out the minus 5. So let me do that. This is going to be limit h goes to 0. So tell me how that would read out there. What is it?
1 plus h cubed
1 plus h cubed
plus 2.
plus 2. And then in parentheses, 1 plus h. Subtract 5. Okay, so that's just your top left, right? That's just this piece. Now, minus f of 1. Minus f of 1, we already know f of 1 is negative 2. And then all of this divided by h. Now, we're guaranteed that that h is going to cancel. We're guaranteed we have 0 over 0. Okay, because of just the way this is defined, it will always be 0 over 0. So we just need to try and hopefully get an h to cancel. So do you see the difference in this problem already from the last one? We're going to have to expand this out. 1 plus h times 1 plus h times 1 plus h. Distribute the 2 through, clean all that up, take a look at what we've got. All right? Yeah, I don't think we're going to need to divide, though. Like, we're not going to need the synthetic division at all.
Well, on this one, since is it always going to be just an h underneath it? Like,
Yes, h will always.
and if the h will cancel
you will probably not have to use the long division. That's right, or synthetic. All right, I'm cubing 1 plus h. 1 plus h times 1 plus h times 1 plus h. You could write them all out. I think in the homework solutions for this section, I actually do it. I write it out and do it. I'm not going to do it in class. But this is this, okay? Then I have this, so 2 plus 2h, right? And then what about these last things together here? Minus 3. All over h. All right, let's clean up the numerator. If I did things correctly, I should get an h to cancel, if I did things correctly. Let's see. 1 plus 2 is 3, but then take away 3. So all those constants are gone. How about like terms? Do we have any like terms? 3h and 2h, so I have 5h. Still writing the limit, right? Notice the limit's still here. 5h, and then h squareds. I just have plus 3h squared, plus h cubed, all over h. Everything has an h in it, right? That's good news, because I can factor an h out of the numerator. One factor of h out of each one, cancel the h's. And now at this point, let h go to 0. Take your limit. And what happens when you take the limit here? Just goes to 5.
So would you recommend using that formula over the other one?
No. I recommend that you understand that they're both equally as powerful. Sometimes this formula will be harder than the other one. It depends on the problem. It really does.
So it doesn't matter which one to choose?
Doesn't matter. I will not tell you which one to choose on the test. I'll just say, go find the equation of the tangent line. I will require that you use one of these, though. Like you can't use your calculator to do it.
Yeah. I mean, so what is there like? Do you see something and right away you're like, okay, probably just right off the bat use this one first.
Okay. Okay, so yeah, kind of. A little bit, I guess. I know that if I use this formula, I've got to replace this and this with a plus h. And so I know I'm going to have to cube it and then just distribute a 2. And I realize that up top then that would just be a polynomial and the denominator is going to be h. That's what I see. As opposed to the other one where I'm going to take this expression, that's f of x, minus f of a, minus a number, but my denominator is not h, it's actually another polynomial. So I'm going to have a polynomial over a polynomial, which makes me think I'm going to need to factor. So, but I think that comes with time and seeing enough problems where you're like, okay, I see those two things. That's what I see. But I'll be honest,
Process of elimination for us, I guess. Like just try it.
pick one. If it looks too bad, go with the other one. Yeah.
Either one will get us there, right?
They both should provide you a route to the correct answer. All right? Yeah, and we got 5. That's good news, right? Okay. So now if I wanted the equation, I would just now follow through with everything we did before, right? I'm not going to repeat that. All right? The way that I look at this with these two formulas is that, and what I recommend for you on your homework is try each of the problems with both. Like do them both ways. And that'll just make you more comfortable with each method. Don't just try and like marry one of them, you know, just like this is the one I'm going to use, even if I have to, you know, my ears are bleeding while I'm doing it, I'm going to stick with this one because I like it. You know, be willing to be flexible here. Yeah. Yes. All right, we need another one. Let's do find the equation of the tangent line of the function f of x equals 3x over x squared plus 1 at the, let me see here. Let's make this a little easier, okay? Just change this to a 2. That way we can go at the point 1, 1. I'll keep us away from fractions right now. So if I go to the computer and I graph this, I go out to the point 1, 1, I'm going to see a point, and then I'm going to kind of have an idea what that tangent line is, right? And I'm going to go try and find its slope right now. We'll do the graph at the end. All right. First, the slope of the tangent line. Well, your choice.
Kind of buried the first one.
Yeah.
You like that? Limit, what, x goes to a, f of x minus f of a over x minus a. I can replace what here? Can replace the a with 1, right? This becomes f of x minus f of 1 over x minus 1.
No.
Where's the A come from?
A is, okay, yeah, where's the a coming from? The a is always the x coordinate of the point. This is a. And remember, this right here would be f of a.
But A is an X, okay.
Was there another comment? I thought I heard another comment, no? So do you see on this one, you're not going to get a polynomial over a polynomial. You're not going to get that. This bottom is going to be x minus 1, but the top is not going to be a polynomial. That's because the original function wasn't a polynomial. So we'll keep going with this. F of x, top left corner of this is going to be whatever fx is. 3x over x squared plus 2. That's the top left corner. Minus 1. All of it over x minus 1. If you take the limit right now and you let x go to 1, you're guaranteed to get 0 over 0. You don't have to check it. So if we're getting 0 over 0 here, what are you going to do? I don't know. So I'm going to stop right here. I'm going to write the other formula up here. I'm going to put them side by side. I'm going to let you choose, and I'm going to let you work them the rest of the way on your own. Okay? So this right now equals, I don't know. Well, you go. We're going to figure that out. But the other person who married the other formula is going to say the slope of the tangent line is equal to the limit as h approaches 0 of f of a plus h minus f of a all over h. And this is going to be limit as h approaches 0. All right, what's f of a plus h? This one is a little tricky. A is 1, right? Let me save us some time. A is 1. A is 1. What's 1 plus h plugged into the function? I erased the function. Wasn't that it right there, though? So 3 times 1 plus h over 1 plus h squared plus 2. So it'll look like this. 3 times 1 plus h over 1 plus h squared plus 2. What? Minus 1, but all over h. There you go. You choose. They both go to 0 over 0. All right, let's make this an in-class group quiz. You can work together. I want you to work this on a separate sheet of paper. Well, you get to choose, right? You get to pick whichever one. You can just write this down, okay? Start from here or from here. And let's be quick. I'm not giving you forever here. No, each one of you do your own. This is more going to be a participation grade than it is going to be you better get to the right answer, because I'm only going to give you 10 minutes to work. Okay? So get as much done as you can in 10 minutes. You can work together. You don't have to work together.